Our next speaker is Dr. Josh Sonnier, who is a mathematician and physicist by training, a software developer by necessity, and a novice jazz pianist by choice. Josh.
Thanks so much. And I said novice jazz pianist instead of awful jazz pianist, but it's a hobby, so I don't have to be good. I just have to love it. So what I want to talk about today is really drill down into one type of use case that we're working on, that my teams are working on at CGI. Closer? I worry I bellow with a very loud voice, so I'm cautious when I'm speaking. So my talk is generative AI, so what? We can do interesting things, we can tackle increasingly complicated problems, but if these don't end up being adopted by communities or research institutions and things like that, then it really stops at being an amazing thing that is also complicated. So I want to talk about the balance between innovation and adoption. So this is a vector subspace embedding of my entire talk. I want to talk about LLMs. I want to talk about innovation being a fuse, not an explosion by itself. I'm going to talk about agents, or intelligent elements within systems that are governed by LLMs. I want to talk about the holy grail that wasn't, which was my personal ambition, that ended up being very short-sighted. And then how do we get to actual adoption for these kind of tools? So LLMs take vast amounts of data, learn a great deal about it, sever a cord to the training data, and then are able to perform almost an arbitrarily complicated set of tasks based on the way you ask them questions. That's what they're good at. They can answer questions, analyze sentiment, all these different things. Another thing that they are extraordinarily good at is enforcing protocols and transforming data. That sounds much less romantic than writing a beautiful poem or helping you complete a grant application ahead of schedule, but it is an enormous superpower that they have. So, for example, I asked the assistant that my team has built, write me a limerick about innovation versus adoption. It did it. I can give it to you afterward. In the interest of time, I'll just say it was fine. It's not great. But I had to really hold the model's hand a little so that it could understand my personal preferences about formatting. But once it got those preferences, it was able to format like clockwork with almost 100% certainty. That, again, sounds a little boring. However, being able to enforce communication protocols is an incredibly valuable thing if you peel back the cover on things like application development. Imagine a very, very simple application. If you don't know anything about software development, no problem. This is a user using a mechanism to get to a complicated system of abilities. In the background of this, we have data, we have background services, we have communication layers, we have all these things happening. Everywhere you see a comma or a dotted line, there's an enormous amount of development effort happening. If I replace it, because what I'm trying to do is get a database to communicate freely with another service, and that has to be done in a very, very particular way to be safe, secure, transparent, explainable, all these things. For something like a data science application, which is near and dear to my heart, we have a user speaking to maybe data services, machine learning services, visualization services. Those are all very, very different services. Whatever your domain is and whatever business you have or whatever your expertise is, all the services that you're using can be very, very different and of varying levels of complexity. However, you know who doesn't care about that? The math. An LLM does not care about that. If I replace the decision making about where to send these requests and what to do with them, instead of building layer after layer with software developers to make sure these things happen correctly, I just make the models aware of specifications. Again, it sounds dull, but what it does, every dotted line and comma and component, every syllable of conversation that has to happen between these services now can be part of an identically structured layer. All these complicated communication layers in the background disappear. They don't disappear, they transform into a single parallel set of communication layers that are configured identically. So, for example, if I ask an LLM, hey, here's some data, can you make a chart? The LLM will say, and everyone has seen this, I'm sorry, I'm just a large language model, I don't even know what charting is all about. Or if it gets increasingly complicated, they can start to do those things. But I can take a very dumb model and say, if I ask you about charting, use this other service. Don't do anything, just turn my question into the kind of question that service wants to hear. So I say, here's some data, plot it. The LLMs don't plot anything. They say, I know how to communicate with that API. They communicate, they also know, because of my request, what the response needs to look like, and they can transform that. Is that my time? At 45 seconds or 1 minute and 45 seconds? Oh geez, okay. So, a slightly more complicated example, quantum computing. Quantum computing is very different from drawing a chart. You know who doesn't care? The math. The communication protocols being enforced by the large language models don't even need to care about that. I say, hey, I want to build a circuit with these kind of qubits, and here's what I want it to do. The model says, okay, I know how to talk to a system that does that, communicates, enforces the proper protocols, and handles the responses. The bottom line on this is that I can begin to tie all of these things together into constellations of these agents, these intelligent decision-making models that don't have to be super smart. The services can be very robust. The models themselves can be relatively dumb. 3.5 Turbo, for the LLM folks in here, can do this like clockwork. This was my humble holy grail when I started. I wanted conversational analytics. I, as an analyst, and my teams of analysts, I wanted to be able to look at a system and say, no. Literally, I want to be able to say, go get that other data set. What do you think I should do? Really? Logistic regression? Great, do it. Is it better than what we did before? What would you suggest as an improvement? Turn that line red, make it animate, those kind of things. And we can do it. This is our conversational analytics agent, or series of agents. This happens to be a seasonal decomposition that was done live and on the fly by our background system, because the services are smart. These are secure execution layers in the background, code runners in a dozen languages. The large language models that can write code do that. They pass it to the computational layers, pass it back. There's no overhead for computation. The fact that my holy grail was a timid one was that works for us. I want to work with this to work for everybody, so we abstracted out the agent building process so that end users can make these connections themselves and build out feature sets on the client side. So if you have a system that you want to do things to, you can do it and let the large language models handle all of the APIs and connectors and things in the background, so your developers don't have to. So that's how we can, this is the kind of thing we can accomplish if we focus on adoption and not just technical innovation. So innovation is a fuse, but adoption is the actual explosion when you begin to see curves do like this. So I had to speed through the end, but that's all. And please collaborate. I work at CGI. Contact us. We love to collaborate. This is just one use case. We have a very broad set of use cases of varying events.